Hello, everybody. Welcome back to the Nibiru channel. This is Scott from Planet X News. Saturday morning. Oh, no, wait a minute. It's Saturday afternoon. Maybe it's morning for some of you. But listen, ladies and gentlemen, we're here today with our doctor, our physicist, and she's written a fantastic report on Carlos Munoz Ferrada. And I've done a lot of reading about Carlos Ferrada for many years. And I have the utmost respect for this man as an astronomer and a scientist. And if many of you are not familiar with Carlos Ferrada, he also delved into researching what we refer to as Planet X or Nibiru. And he named it, I'm going to try this one time, Hercolubus. Hercolubus. The red planet, the red Comet Planet. And a lot of his studies were very, very interesting. And Carlos Ferrada himself was a very interesting man. I personally think that his name should be spoken in the names like, for instance, Albert Einstein, Thomas Edison. He was a very, very great man. And he saved a lot of people's lives with his earthquake predictions, not forecasting, predictions, and he was spot on. But the doctor has taken some time, and she's gone in depth into Carlos Ferrada, and the reason why she wanted to do this was to simply bring you another angle, another opinion, and more research into what is happening. So, ladies and gentlemen, you have to understand that this has been going on for a long period of time. The United States government has known about this for probably over 35 years, maybe a little more. Other governments followed directly behind the United States, and they basically shut the door. But before all of that U.S. research was occurring, Carlos Ferrada was way ahead of all of these people and all of these governments. And he noticed this object, and he referred to it as a planet with comet-like features. Hercolubus. Hercolubus. Very, very interesting man. He was a Chilean astronomer. And I respect him and his research and his intelligence. I have the utmost respect for this man. Now, he's passed away now for some years, and he was very old, but I still hold all of his research to heart. So we wanted to bring the opportunity for all of you to find out more about other people who've been researching this Planet X or Nibiru. You know, it doesn't just start with Dr. Robert Harrington, Zachariah Sitchin. I believe it starts with Carlos Munoz Ferrada. And the doctor's done a fantastic job with her report, and she's going to go through all of this and explain it to you. By the way, good afternoon, doctor. How are you?
Good afternoon, Scott. I'm very well, thank you. And you?
I'm doing very, very well. I just spent a few minutes outside, and I could see the sun simulators out there. They're already chemtrailing, and they've taken a beautiful 76-degree day, and they turned it into complete crap already. 1 o'clock in the afternoon. So, you know, my theories go, if they are chemtrailing this early, then something must be there, because the chemtrails are only in front of the sun. If you look the opposite way in the sky, it's crystal clear. So, you know, maybe they're behind schedule on their geoengineering. I don't know. But I'm going to go, I'm going to go ahead and I'm going to pull up your report.
Okay.
Give me one moment here, because I'm very, very interested. I was able to read a good bit of it, but I'm very interested in getting you started because I really respect.
Thank you.
I really respect the research of Carlos Ferrada.
Okay.
Okay, you able to see that?
Yes, I am. Thank you, Scott. Right. So in the 1990s, Carlos Ferrada announced that an object was on its way into the solar system, and it would pass by Earth at a distance of 14 million kilometers. And that is a distance of 36 times the distance between the Earth and the Moon. So it's not that far. And yet it is quite far, but it's quite a large object. So you can see it there. That's an artist impression. The object, he said the object was 6 times larger than Jupiter. And so that's what it would look like. And you can see there Jupiter and Earth, so you can compare the sizes. Jupiter is 10 times larger than Earth. And this object would be 6 times larger than Jupiter. Right, so if we move down a little bit more. Now, he predicted earthquakes, specifically 3 very strong earthquakes. And he started with the 1939 Chilean earthquake. That earthquake killed 50,000 people and left 60,000 injured.
50,000.
Yes.
50.
It was.
Oh my dear God, I forgot about that.
Mm.
That's right. That was the 1939 Chilean earthquake. It killed 50,000 people. And yeah,
right.
and 60,000 injured. I'm sorry, I didn't mean to interrupt you, but I forgot all about that specific earthquake. And yeah, okay. I'm sorry to interrupt you, but yes, ladies and gentlemen, 50,000 people, 50,000 people died on that day from one earthquake.
That's right. And he predicted this earthquake to the day. I think it was only 2 hours off. And then there was the other one. This was the largest earthquake ever recorded. And that was the May 22nd, 1960 Great Chilean earthquake. And the magnitude was between 9.4 and 9.6.
My God.
And yeah, that's extremely strong. He also predicted that one. And then he predicted one other one in 1985. And this one caused a lot of damage. It wasn't as strong in magnitude, 7.8 to up to 8. But it seems that it was made up of 2 events that happened within seconds of each other. And this earthquake happened, the epicenter was 25 kilometers offshore. And yet it was able to destroy and cause extensive damage to buildings 200 kilometers away from the epicenter.
Wow.
So he also predicted that one. I think the first one he predicted, people didn't take much notice of what he was saying. That's why so many people were killed.
Yeah, that's correct. I do remember reading that in, I read a long article pertaining to Carlos Ferrada. And, you know, a lot of people thought he was crazy. Don't listen to him. He doesn't know what he's talking about, you know, that whole scenario. And just like you said, boom, you know, that massive earthquake, 50,000 people lost their lives that day. But in the future, people listened to him.
Yes. Yeah. The most interesting thing that I found out about him was he was an astronomer and how he made his observation. And it seems to me from what I read that he actually observed the sun. And he said that earthquakes are not due to the fault line slipping or things like that, actually. They have something to do with the interaction between the sun and other stars. So he could see these interactions by observing the sun. And then if he saw something happening on the sun, I guess he would aim his telescope in a certain direction to see what was there. But mainly he observed what was happening with the sun. And what was happening with the sun would then affect the Earth. And he then came up with some way of calculating exactly where and when the effect would be felt on Earth.
So kind of almost like we do now.
Exactly. Because the brown dwarf stars, of course, are affecting the sun, and the sun is affecting the Earth. And I mean, that's what we see, the coronal holes, the sunspots. A lot of what's happening with the sun is due to these brown dwarf stars. The fact that it's getting darker, it's not emitting as much light. It's all due to these stars interacting with the sun. So this is what he was observing as well.
Very interesting.
Yeah. Right. So he came up with his prediction for this Comet Planet. And there were some characteristics that he stated it had, and one of them was that it emitted mainly infrared light, and it has an elliptical orbit as well as a tail, so it was a bit like a comet. That's why I called it a comet planet. Then it was 6 times larger than Jupiter, and it was red. It will eventually be clearly seen in the sky from Earth as a second sun. And that immediately should tell you something. This object is a light source. In other words, it's not just a planet that reflects light. It actually emits light. So from that, you start to realize that what we call brown dwarfs and brown dwarf stars that emit light because they are stars are very likely to be the same type of object he's referring to. He just not using the same terminology that we're using, but I think it's the same type of object. So I will go further into that. Then he said it travels between the black sun and our sun, and that the black sun was at a distance of 32 trillion kilometers, which is 214 AU from the sun. Remember, 1 AU is the distance between the sun and the Earth. And then he said it does not obey conventionally established physical laws. And that for me is extremely interesting, because that has been our observation as well. That I've often said these objects do not obey normal physical laws. They seem to, for example, act as if they're protons and neutrons in the nucleus, and these stars attract each other like that. So that's very interesting. And then he said it is charged with cosmic radiation, and it brings destruction, epidemics, stress, and wars. So what I'll do is I'm going to try and explain what it was that he said in terms of what my own understanding of what's happening in the solar system is, because we've been observing these objects. And you, Scott, have taken, this is your photograph that you took with your telescope. And as you can see there, this is a brown dwarf star. This is the characteristic brown dwarf star. It looks like a cloud with a hole in it. And it's shaped in a thick ring. And inside that hole, what there is the core of the star. And this one is at a stage where the core is not emitting light, but possibly the cloud is emitting some light. And therefore, we see it as white here. So these objects mainly emit infrared radiation. So when they come into the solar system, they are dark. And then soon after they come in, we start having plasma discharges between the core of the object and the cloud of gas, that thick envelope that surrounds the core of the star. And then it starts being able to emit some light because of those discharges in the cloud.
Now, you know what, Doctor, I just wanted to mention one thing. Based on all of Carlos Ferrada's research And,
Mm-hmm.
now we're talking about brown dwarf stars. But back in his day, they had not discovered brown dwarf stars, correct?
That's correct.
Yeah, they weren't even in the astronomy lingo. There was
Mm-hmm.
no definition for a brown dwarf star.
That's right.
They've only made, well, I really hate to use this terminology because I'm so upset with a lot of astronomers around the world because they won't step up to the plate and admit to what they're finding. Only if they are like 55 light years away.
Mm-hmm.
But they are making leaps and bounds over the course of the last 10 years pertaining to brown dwarf stars and classifying all of these dwarf stars. So there are many classifications, but it's only been about the last 10 years that they've really, really made progress in talking about these brown dwarf stars.
Mm-hmm. That's right. So what I try to use is my own observations of what's happening in the solar system. When I started, I knew about brown dwarf stars, and I immediately saw that these objects in the solar system were behaving like brown dwarf stars. They were emitting infrared light. They had clouds of gas around it. And to me, a brown dwarf star is a cool down white dwarf. And a white dwarf has a core and has an envelope around it. And then further out, it's got another cloud of gas, which it ionizes. And because I believe in electrical theory, I believe that these are electrical objects. They're like batteries. They have electric potential energy, and they generate an electric field and therefore ionize the cloud of gas. So to me, there are, because of these similarities between white dwarfs and brown dwarf stars, and the fact that the brown dwarf stars now only emit infrared radiation, at least when they come into the solar system, I immediately made the connection. These are brown dwarf stars. That's where it all started. But they are able to regenerate. So when they come into the solar system, they absorb energy from the sun, and eventually the core of the object starts being able to it starts being able to fuse its cloud more and more. And eventually the surface of the object where the cloud is attached to, it starts having fusion reactions, or at least it seems to. And then it becomes like a main sequence star again. So it emits a lot of light like main sequence stars, but perhaps not as bright as our sun, but they are a lot smaller. And that's basically what I believe is happening to these objects.
Yeah, well, that was just proven by, I believe, a team of astrophysicists and astronomers that these brown dwarf stars are able to regenerate if they have a source, just like a host. And when they do have this host and they do make this connection, they do have the ability to regenerate and then start to emit small amounts of visible light.
Yes,
so there are possibilities, ladies and gentlemen, that a lot of the things that we are seeing in the skies, we cannot discount anything. Because if we discount something and we don't pay attention to it, then we may be missing a valuable piece of evidence. Whether someone wants to think that it is a lens flare or a camera artifact or a reflection, well, listen, that's their opinion. But we cannot discount anything at this time. We just cannot. So everybody's going to have their own opinion. I fully understand that, and I'm sure the doctor does also. But getting into looking at photographs and different videos and things of that nature, you have to look at them very carefully. You have to look at them with an open mind, and you do have to kind of understand what you're looking at. There are big differences in lens flares, and I really don't want to get into the whole lens flare conversation. I had this conversation a few days ago with a few other folks on the Planet X Facebook page, and I basically brought all of them up to speed on what a lens flare really is. And you yourself, if you're not sure what the firm definition of a lens flare is, just Google it, look into the images, and you'll see what lens flares really, really are.
Mm-hmm.
So we cannot, take for granted what we're seeing in the skies, because someone may take a very critical photograph and be too afraid to show the photograph in fears of being ridiculed. But you don't have to worry about that with me or the doctor. We will examine all of the photographs, all of the video, and if we see that it may be a lens flare, we'll politely tell you that's what it is. But if it's something that we are just absolutely not sure of, we're not just going to label it a lens flare, a lens flare. We're going to look into it further. And, I will be the first to admit, we have a lot of photographs and a lot of video that are just completely unexplainable. And this is almost like talking about UFOs. Sometimes you have something up there in the sky that you took a photograph and it is unexplainable. But we do need to stay on point and continue with all of our observations, because it's a big, big help.
Mm-hmm.
So do you need me to pan down on the article?
Yes,
here?
please, Scott. All right, so Carlos Ferrada also said that the object looked like a comet. And there are two ways that brown dwarf stars can look like comets. First of all, comets have tails. And these objects, when they come into the solar system, they have a cloud of ionized gas, and they have debris following them. So as they come into the solar system, the core of the object will be able to ionize the cloud of gas, and also it interacts with the solar wind, just like the atmosphere around the comet interacts with the solar wind. So you would expect it to eventually give off some light, just like a comet's tail. So you see here in the illustration of what the Comet Planet would look like with a tail behind it, which is a cloud of gas and debris, which is ionized, and it then looks like a comet's tail. So that's brown dwarf stars are expected to be able to do something like this as well. And then the other thing is comets actually produce jet-like plasma discharges between the nucleus of the comet and the cloud of atmosphere that forms around it. And that's exactly the same that happens with the brown dwarf stars. They have plasma discharges from the core of the object to the cloud, the envelope, and then sometimes also in the cloud, the more diffuse cloud surrounding that. So the same thing happens with both these plasma discharges. So in that way, we see that the way he named the object, Comet Planet, fits exactly with what we would expect brown dwarf stars to do in this case.
I like your illustration there. That's absolutely perfect, because I mean, that's basically what you would be looking at. You'd be looking at the object, and behind it,
Mm-hmm.
you would see a huge, long stream of the debris field.
Mm-hmm.
And some have said that, talking about planet Nibiru, that it has a debris field stretching over 1 million miles long.
Mm-hmm.
Now, taking into consideration, I don't know how anybody would ever be able to come up with that type of assessment and measurement, but the fact of the matter is, these objects are substellar objects. They are moving through space. I'm sure that over, tens of thousands of years, they've picked up a lot of riders, a lot of hitchhikers on the way. So, for them having a very, very long debris field, I would definitely think that that is very, very possible.
Oh, yes. Yeah. That's right. And then don't we have brown dwarf stars, and we have brown dwarfs. And again, these are pictures that you took, Scott, through your telescope. And on the left, we have the surface of the blue brown dwarf, and you can see because of the grooves in it that it has a solid surface. So it's not like a gas giant planet with a gaseous atmosphere. This is a solid, it looks like the solid core. I would think it's the solid core of the brown dwarf star, but it's reached a stage in its development where it's no longer able to ionize the gaseous envelope. So its energy has dropped. So it's shedding it. And you can see on the right-hand side how much it's shedding. It's shedding layers and layers of its gaseous envelope. And you see a lot of debris around it.
Yeah, and this object was very, very close to the sun, almost within within the sun's corona. And
Yes.
I mean, these objects are some of the oldest known objects in our galaxy, I might as well say, because nobody wants to believe that anything like this is in our solar system, and they're very, very wrong. But it is in our solar system. There are many other objects in our solar system, and believe me, when you go outside like I did today at 11 a.m. and you know the sun looks like the shape of a lemon, and they are chemtrailing the living hell out of the sky, but only in front of the sun. And then with a temperature of only 76 degrees, the sun is burning your skin. I took a drive to the store at 11 a.m. They were already out going back and forth and up and down and trying to block out the sun. And I was sitting at a red light in my car. I had my elbow kind of out the window for maybe a minute, minute and a half. And just in that minute and a half, I literally can feel my arm burning like somebody was holding a match to it. And it's only 76 degrees.
Sure.
I hate being pricked like that. But yeah, these were pretty amazing photographs. And this was the photographs that the trolls referred to as Scott's dirty blue beach towel.
Yeah. But as you can see, the detail on the left-hand side is amazing. It's a real object. This is real evidence that these objects are right here. They are right there, so close to the sun. And they keep pointing us to the Kuiper Belt, but we have these enormous objects. This object was about 3 times the size of Jupiter. We have these enormous objects right there next to the sun, and but they're trying to divert our attention away. So,
you know, I was just thinking maybe this photograph, maybe it could have been a blue paint chip in my telescope, even after it was professionally cleaned. You know, ladies and gentlemen, whenever you're cleaning your telescope and cleaning the mirror in your telescope, you know, you definitely have to know what you're doing. And you never, ever use any type of cleaning products like Windex or, you know, anything like that. You don't use anything like that cleaning your telescope, because you could actually get lint or little finite pieces of debris. But even if you did, they would not look like anything like you're seeing here. And the fact of the matter is, on May 10th and May 12th, this object was photographed in different locations near the sun. So the fact of the matter is, it's there. Now, we're considering this to be one of the brown dwarfs, not one of the actual stars. And it is an amazing looking object. The object that you're seeing to the right-hand part of your screen, I did try and use some color contrast to bring out some detail in this object for all of us to see more clearly. And I mean, it's very unusual looking, and these astronomers and scientists have said that there are different colors of these brown dwarfs, magenta, a dark reddish brown, and some of the oldest substellar brown dwarfs will have this blue color to it. And then lo and behold, here we are. Here we are.
Mm-hmm. That's right. It's amazing.
Yeah, it definitely is.
Absolutely. Yeah. Well, we have evidence. At least this is amazing evidence.
Yeah, I mean, there's no doubt about that. And you know, ladies and gentlemen, you're always going to have your naysayers. You're always going to have your people that call you a liar and a fake and a cheat and a criminal. And you know, I mean, I don't see how this is criminal. You know, informing or trying to inform the world population of what's occurring. You know, here's something that I thought about the other day. When astronomers come up with a discovery and they publicize it, are there people there standing on the street with picket signs yelling, "You murderer, you criminal, you fraud"? I mean, I just don't get it. Are they jealous because they didn't make the discovery? Who knows? Are they trying to cover up what is there? Probably. Is it a big conspiracy? Yes, it has been for more than 35 years. But we're uncovering the conspiracy. And they don't like the fact of the matter that we are drawing light to shine upon what is actually happening. And, you know, we're not going to stop. We're going to continue with our observations and our research because we have every right to do that.
Mm-hmm.
Mm-hmm.
That's right. That's right, Scott. And my observations has led me to the conclusion that the brown dwarf stars and the brown dwarfs are connected. And that is basically that brown dwarf stars eventually turn into brown dwarfs. So the brown dwarf is just another stage. So if we scroll down a little bit, I think there's a diagram where I illustrate that.
I love your diagrams. You do such a good job on these diagrams.
Thank
Wow,
you.
look at that.
Yeah.
Look at that.
So here we start with when these objects first come into the solar system, they completely dark, no visible light. And then shortly after, they start being able to emit light from the envelope. And that's what we see right at the top there. It's the front view and the side view of a brown dwarf star. You see the thick envelope. The core is still dark, but we see the envelope as emitting light. That's why it's bright there. And so that would be, that's the first stage I put in this diagram. And then slowly it starts being able to emit light from the core of the from the surface of the core of the object. It probably has fusion reactions on its surface. And then we start having light being emitted from the core. So that would be the second diagram down there, where you see the yellow center. That is the core emitting light. So that's the brown dwarf star stage. Then it starts turning, and this, don't forget, this can take a long time. It could even take millions of years. I have no idea how long it takes. All we are able to observe in the solar system is these objects in different stages of this development. So we see the first stage, which is the brown dwarf star with a dark interior, and then the brown dwarf star that does not have a dark interior anymore. It's emitting light from the surface. And then we get, I've put in now 2 brown dwarf stages. And that is because it should go through a gradual transformation from one to another. And the final one would be the blue one with still some a certain amount of gas envelope sticking to the core of the object, like we see on the blue-brown dwarf. And then I would expect that between the brown dwarf star stages and the final brown dwarf stage, we would have a brown dwarf stage where the object does not have a thick envelope, maybe anymore, but it does have gas surrounding it enough, and it is able to still ionize that gas, and it is still able to emit some visible light. So that's the orange object over there. Notice as well that I've made sure that they look like they grow in size, because that's what we observe, that brown dwarf stars are much smaller than brown dwarfs. And so
there's my big blue planet right there, my big blue dwarf.
That's right.
My dirty towel.
Yeah. That's the blue-brown dwarf you discovered.
You know,
so this is what
I really want to. I really want to try. I really have been trying my damnedest to capture that object again, but as of lately, you know, I haven't had clear skies. We've been having very early evening rainstorms. We had one late yesterday. Wow, it was. Whew, the sky turned green, and then it just opened up. It sounded like World War III.
Oh my goodness.
Yeah, it was definitely something. And you know, we're getting ready to head into the 4th of July holiday weekend coming up here in the United States. And when I took my ride this morning, you know, they were already setting up a few days ago all of the 4th of July tents to sell fireworks. Well, when I went by it the day before yesterday, all of these big tents were up. When I drove by it this morning, they were all gone. They had all been, they were all destroyed from the storm. Oh yeah, they were done. They were gone. They were down on the ground in like pieces.
Oh my.
Yeah, most definitely. We're definitely seeing some very, very crazy weather around the United States. And like I've said before, folks, it's not going to get any better. It's actually going to get pretty bad going into the month of July and August and September. I think we may see a very, very big continuance of this going into November. And we possibly may have another very, very extremely warm winter in the Northern Hemisphere, if we get that far. Now, I'm sure we probably will, but, you know, I'm really not like a date setter, but just going by my observations with what I've learned about weather over the past 20 years, it's not looking good. It's not looking good at all for the Gulf of Mexico region. That much is for sure.
Yeah.
So shall I pan down?
Yes, please, Scott. So the other thing that Carlos Ferrada said was that his Comet Planet was red. And now, if we have a red comet planet, we would expect it to emit red light, and then we could perhaps have a sky looking like that, that's another photograph that you took. And in this photograph, there's actually an object in the sky, possibly the source of this light. I don't think it's a planet, because if it was a planet, we wouldn't see it through the clouds. So it's a source of light, and the source of light is, of course, a star. And now, don't forget, these objects, when they come into the solar system, or the brown dwarf stars, emit mainly infrared light. If they go into the brown dwarf stage, the intermediate brown dwarf stage, where they still emit some light, then we would expect that the visible light they are able to emit would be the weakest visible light, closest to infrared, and that would be red, because red light is of lower energy than blue light.
Yeah, this is an amazing.
So,
Amazing photograph.
Yes.
Who took this photograph?
I think you did.
I'm just testing you, doctor, to make sure you're on your toes.
I think you took this.
Yeah, I took this.
And
I took
it's
this photograph.
absolutely.
Yeah, ladies and
it's
gentlemen.
amazing.
On this day, I happened to step outside, and I think it was just about around 7 p.m. This is not more than a few weeks ago. And I noticed all of my neighbors were standing out in the street, and they were all pointing up, looking. Some people were taking pictures with their cell phones. And, I just kind of keep myself quiet, and I really don't talk about too much of this with my neighbors because the majority of them are elderly, and I don't want them to, get super scared. But when I looked up at this, I was just completely amazed at what I was seeing. So I decided to snap a few photographs. And then whenever I reviewed the photographs, I said to myself, what in the hell is that? What is that? And then I zoomed in on it, and I didn't play with the color. I mean, what you're looking at is the original photograph, and you can see a perfectly round object here. I don't know about any of you, but I've never seen a cloud perfectly spherical, and there it is.
That's right.
And the color, I mean, wow.
Yes.
And looking back at this, if you look over here, you can see the sky was blue, and then it just fades into this Martian pink. I call it alien skies is what we seem to have nowadays.
That's right. Because it's not possible to have clouds transmitting this kind of light if they are not being illuminated with this light. And if they are being illuminated, there has to be a source of this light that is emitting this frequency of light, which is red light. And again, remember that Carlos Ferrada said that his Comet Planet was red. So it's possible that it is the same object. On the other hand, so many of these objects have been coming into the solar system. There could be more than one.
Very amazing. Very, very amazing photograph. It is pretty cool to look at. But, in the same, I guess in the same words, we really shouldn't be seeing things like that in our skies. Even though the pink skies are, breathtaking and very beautiful to look at, we really do have to look at this beautiful picture and, consider it a threat to our planet because it's not normal. No matter what anybody says, folks, this type of situation is just not normal. And we are seeing it more and more and more every single day all around the world. I have so many photographs. I can put together probably a 24-hour video stream of just these bright pink, iridescent looking skies that, are just unexplainable. Now, some people say, oh, that's just the reflection of the sun on the clouds. Well, again, in my 49 years on this planet, and I've traveled quite a bit, I don't ever remember seeing anything like this ever.
Yeah.
I don't know. It's pretty amazing.
Right. So these objects have large magnetic fields. And this is the way they are able to interact with the sun. It's through their magnetic fields and how they are able to drain energy from the sun, drain plasma, and so on. But what is strange as well is that, don't forget, white dwarf stars are very small. They're about the same size as the Earth. But brown dwarf stars are much larger. They're about the size of Jupiter. There was one that was about 1/3 the size of Jupiter, but that's the smallest. They go up to about twice the size of Jupiter. The first one we observed was 1.7 times. So they seem to grow in size in going from the white dwarf stage to the brown dwarf stage, and then the brown dwarfs are even larger. And yet there isn't actually, and their masses seem to decrease, because the mass of these brown dwarf stars is much less than that of a white dwarf star. And the brown dwarfs seem to have even less mass. So from that, I gathered that mass does not depend on the number of particles. So what we see here in this diagram is at the top, the orange little circles represent a certain amount of matter. So the particles, there's a certain number. In the bottom picture, we have the same number of particles, but the particles in the upper diagram have a larger or a higher electric potential energy, and the ones below a low electric potential energy. So the orange ones at the top are able to generate a large electric field, whilst the ones at the bottom, the purple ones, generate a small electric field. But it seems that the size of the electric field they are able to generate corresponds to the amount of mass they are able to generate as well. In other words, mass is not a property of or the amount of matter. We've always up to now thought, okay, we have so many particles, therefore each particle has a certain mass, therefore all these particles will have a certain mass. But yet, what I've observed in the solar system is that this is not true. This is mass itself is generated just like the electric field is generated. Or in other words, the gravitational field is generated just like the electric field is generated. So what we have on the right-hand side is the orange particles generate a large mass, and the purple particles generate a small mass, because they have a lower electric potential energy. And then from the mass, we get a gravitational field. So the orange ones generate a large gravitational field, and the purple ones generate a small gravitational field. And this is what I mean. I have been saying for a while that it seems from these observations that these objects, that mass is not an intrinsic property of matter. And this is what it means. It does not depend on the amount of the number of particles, but on the electrical potential energy they have.
Very, very, very interesting. Very interesting. This gets me more and more thinking about the electric universe.
Yes, indeed.
Which nobody likes to talk about.
That's right. And it's amazing that what we discovered is that the gravitational field is generated just like an electrical field. To me, it's absolutely amazing. So that's basically that diagram. Then Carlos Ferrada also talked about the black sun. And the black sun would, of course, be a star that does not emit light. So what we have in the solar system is brown dwarf stars that come in are not able to emit light. So they are black stars in the beginning. So this is exactly what he saw. And we are putting two and two together. It seems to me that he saw coming towards the inner solar system a black star and a brown dwarf that is still able to emit some light. And it was emitting red light. And we have these objects here now. They've been coming in for a while, for many years. Now, this is another one of your pictures, Scott. You remember this one?
Oh, yes.
So what we have here is an object embedded in the sun. So that's where the blue arrow is pointing. And I know it's on the right-hand side, but that's actually the south pole of the sun, because we see the sun on its side when we're standing on the surface of the earth. So that's the south pole. And at the south pole of the sun, there seems to be an object embedded in the sun. And this goes together with what Carlos Ferrada said about the fact that they do not obey conventional physical laws. These objects are attracted to the sun, and they can come right up into the sun's corona. And as you can see here, one is actually embedded in the sun. So to me, it looks like they are obeying a type of a strong force, and they're behaving like protons and neutrons in the nucleus, where the strong force keeps them together there. And therefore, it seems that the strong force is acting on an astronomical scale. And that is beyond anything that we've ever heard about, that was even possible. And here we are, and we're seeing it.
You know, one thing that did, you know, kind of scare me a little bit about this photograph is that there were other objects here.
Oh, yes.
that were probably so far off in the distance they were not illuminated by the sun, but they're very faint. Let me go ahead and just, I mean,
yes.
you can, there is one here. And there is
That's
another
right.
one here. And the more I zoom into it, it will pixelize a little bit. But, you know, these are untouched. These photographs have not been doctored, no contrast, no color, nothing. You're looking at the raw photograph. You can see the object right here.
That's
and it's
right.
being slightly illuminated by the sun here, almost like a crescent moon.
Yes.
And then this object it's getting pixelized a little bit. Let me move over here. Let's try to center this. You can see it right here.
That's right.
And again, these objects are not directly up into the sun. They're off in the distance. They're probably pretty far from the sun, but large enough to be seen.
Yes, Scott, I don't think they are that far in the distance, because don't forget the sun is huge. And if they are far in the distance, they would be larger than the sun.
Well, I meant like, you know, like far enough where
Yeah.
they could be actually visible and not blocked away, you know, from the sun. So they must be at a little bit of a, well, I don't know, maybe I'm using the wrong terminology, but a little bit of a higher elevation, higher altitude. No, altitude's the wrong word. I don't think you use altitude in space, do you?
Well, we could say maybe they're above the sun and a bit behind the sun.
Yeah, exactly.
They don't seem to be emitting a lot of light, so these could be brown dwarfs. I wouldn't be surprised. But it goes to show how many of these objects there are around the sun. There are so many. If we were continuously able to watch the sun without all the cloud cover and geoengineering, we would probably see dozens of objects around the sun every single day.
Yeah, I think they're orbiting the sun now. I think they're orbiting the sun now in a much tighter orbit than was you know, documented last year, because I really started documenting things in mid-July of 2016 and for the rest of the year. But it seemed that in the beginning of October of 2016, I lost these objects. I didn't see them again for, I think it was about 3 months. But they were now being seen in the southern hemisphere by people in Australia, New Zealand, and different areas, but not too much in the northern hemisphere. So it's very hard for us to, you know, well, try to predict or try to calculate what type of orbits these objects have. You know, we don't have an observatory type, you know, telescope, or have access to an observatory where we can really find them. Boy, I'd love to step foot in an observatory.
Oh, yeah.
I'd spend a month there. I'd live there
Uh-huh.
just to prove it again,
Yes.
beyond the shadow of a doubt. And even if you would prove it, you're going to still have a whole line full of naysayers out there that say you're a liar.
Hmm.
But anywho,
Yeah, Scott, I think these photographs you have taken with your little telescope are just amazing. They are evidence beyond anything I ever expected to see. Don't forget, I started out just looking at the SETI images and realizing there are brown dwarf stars here from what I was seeing there. But to see this kind of evidence, it still amazes me. I'm
yeah.
so thankful that you were able to take these photographs.
Yeah, I mean, I go back from time to time, and I do look at them, and I've run them through several different photography programs. I've run them by a friend of mine who he's a professional photographer for more than 25 years. He has his own photography studio. He's a professional. He has all kinds of digital equipment and programs and things of that nature. And for the last year, I've been scaring him to death because, he knows nothing about astronomy, but, a lot of the photographs that I have taken to him from many, many other people, the only conclusion that he comes to is that is definitely a light source. That is definitely an object there. It's not a reflection. It's not the lens flare thing. He doesn't even use those words because he was the one who actually schooled me on the proper definition of lens flaring. And his son has taken up digital photography as a career. And I never knew this, but do all of you know that people in digital art, they pay for professional lens flaring? They actually pay for digital lens flaring in cameras, in video, in photographs to be used in all sorts of ways, from commercials to different types of photograph advertising. And then his son showed me some of this, and it was pretty wild, but it looked nothing like what the naysayers yell: lens flare, lens flare, lens flare. So they really don't know what they're talking about. It's just a term that they've captured probably years ago to deny what is actually there. So if any of you have a few minutes after you watch the live stream, go to Google, type in lens flare, and then type on images and take a look at it for yourself. And then compare the real definition of what a lens flare is to what is being shown. And then you'll see very, very quickly that lens flare is not the proper terminology for any of this. That's all I have to say on that subject.
Yes. Good. Okay, so maybe I can continue and say, well, we're talking about the conventionally established physical laws. Carlos Ferrada said this object did not obey those laws, and he mentioned that it had 3 different speeds. And that to me shows that there was more than one force acting on it. Now, the gravitational force is a very weak force, but it's still a good model for an attractive force acting between 2 objects. And but if we have more than one force acting on the object, say for example we have the strong force and we have electrical attraction perhaps, or electrical repulsion, then the 2 cannot be easily combined and modeled with a gravitational force. And that you could possibly then end up with what he saw, which was with the object moving at 3 different speeds depending on where it was. in relation to the black star. It's very strange, but yeah, that's what he observed, obviously.
Yeah, I think that there's definitely, more time to look into Carlos Ferrada's research. I personally, I wish I had access to all of his research, all of his papers, everything. And it just seems like once again, like with Dr. Robert Harrington, they sealed all of his research. We'll probably never see it, ever.
Yes, and I think Carlos Ferrada actually had been observing these objects for a very long time.
Yeah, me too.
And he didn't bring them out into the open for a very long time, until he was very old. Perhaps he knew that the powers that be would not allow the information to be made public.
Yes. Yes. He never turned over any of his research. He kept all of his research comfortably to himself in a way. And I believe, he was very, very old, and he gave one last interview to a Hispanic reporter. And that interview, you can find that interview on YouTube if you just, Google Carlos Ferrada interview. And it's translated, but it's very interesting. And he's a frail little, Chilean man. And you just got to love him to death, But it is very intriguing. And I wish, I only wish that in our today's times, I only wish that we had these men with us right now.
Yes.
Because I think that they would be making a huge difference in the science community. And yes, there would probably be people out there trying to shut them up and silence them like they do to, the doctor and myself. But these two men, they have historical evidence. And even though it was a long time ago, it just goes to show all of you that this has been going on for a long time. These objects have been coming in for a long time. And today, this is what we're faced with.
That's right.
And we are faced with trying to gain more knowledge. And that's all we're doing. We're just trying to gain more knowledge. And like I said yesterday in my live stream, we are all here together as a family, as a team. I don't view any of you as, quote, subscribers and viewers. If you're here with us, you're part of this family and you're part of this research team. And again, with all of the photographs and all of the video and all of the observations and all of the information that comes into my channels and my email and the Planet X News Facebook page, tremendous amount of information, and I am overwhelmed with it. And the doctor has been helping me tremendously with all of this. And, in the weeks to come, we're going to be sorting out different ways for us to handle all of this a little more efficiently. And we're going to start getting more and more and more of this information out there, so everyone has the ability to see it, because you have the right to see it. Am I correct, doctor, or what? Am I?
Absolutely, Scott. Don't forget that Robert Harrington lost his life because he wanted people to know the truth. And Carlos Ferrada also wanted people to know the truth, that these objects were on their way to the solar system. They didn't realize that possibly there was more than one system coming in. Robert Harrington probably saw one system. Carlos Ferrada probably saw one system. But they wanted people to know the truth. I think truth is very important. Even if it's bad news, it's better to know what is going on than to be kept in the dark.
Yeah.
And this is what I believe I should be doing, and that is telling people the truth. And I must say, I am fascinated because I am a physicist, with what's happening in the inner solar system with these objects. And it's shown me that the laws of the universe are not quite what we've known up to now. These observations are changing what we believe the physical universe really is and the laws that it obeys. So it's very important to be able to study these objects and gain a proper understanding of what the universe is all about. And this is what physics is all about. This is what astronomy is about. This is what astrophysics is about. And the fact that it's being kept hidden is a travesty.
It is. It is.
Yes.
It's horrible. It's horrible. You know, it actually gets me very upset when I have to think about that, because nobody should be denied the way, this is just my opinion, but nobody should be denied an education in this world. Forget about the different countries, but on this planet, if we took the time to educate everyone, then the world would be a better place, because I truly believe knowledge is power. I've said that time and time again. And that's all that we're trying to do, is we're trying to give the people the power. And that power is based in knowledge. Mm-hmm. And yet we're ridiculed for it. We're put down for it. You know, we're trolled for it. But, you know, I mean, it doesn't bother us. We understand it comes with the territory. But the fact of the matter is, you know, myself and the doctor and many others have given up a lot to come here today and continue to bring the information in a scientific format so we can all understand it. You know, because I'm sure the doctor could, sit here and rattle us away with pure physics that a lot of us would probably not understand. And I think she does a tremendous job of breaking this down into layman's terms so we could all understand it. And therefore we gain that knowledge, and we gain that knowledge at the same time we gain that power. And they don't want us to have that power. But you know what? Too bad. Too bad. We're getting it.
Yes. Thank you, Scott.
Yeah, you do a tremendous job.
Thank you. All right. So Carlos Ferrada also said that this object was charged with cosmic radiation. And I think what he was referring to, and is what we have observed with these objects, is that they have very high magnetic fields. They have high electric fields, which is how they are able to ionize their clouds of gas. Now, and because of that, they have an influence on the sun, and the magnetic fields will cause the interior of the planets to warm up, and this would lead to many changes. And he talked about how bad the influence would be, how destructive it would be to the Earth. So we would expect changes like increase in volcanic activity and earthquakes. And these are destructive, of course. And that goes with what he said. And then the strong fields would also affect the human brain. And Carlos Ferrada mentioned that it would bring a lot of stress, and we would expect that these fields would have that kind of effect on the human brain, leading to a lot of stress and anxiety, things like that. So again, we have what we have observed from these objects, the strong magnetic fields, strong electric fields, with what Carlos Ferrada said, and his terms was cosmic radiation.
And we're seeing a lot of that, aren't we?
Oh, we are. And we're seeing more and more of that. I believe there was an earthquake in Africa again, in Mozambique.
Yeah, magnitude 5.8 and another 5-pointer offshore. I believe, what is that, the Indian Ocean?
That's right, yeah.
Yeah.
So
yeah, we're going to see. We're definitely going to see an increase in the earthquake activity going through the month of July. And you know, ladies and gentlemen, if you live in earthquake-prone areas, you know, heed my warning. there's not much you can do as far as, knowing when it's going to hit. But at least if you have that preparedness plan, in the case of an emergency, you know exactly what you're doing, you know exactly what you should be doing, and you know exactly where you should be going. And you have that bug out bin. Like I said, get yourself one of those plastic bins. They sell them at most department stores, Walmarts, and pack that with all of the proper things that you think that you're going to need. And all too often people lose all of their important papers, life insurance policies, birth certificates, deeds to your home, all of that stuff. But if you buy one of these bins and you put a small medical kit in there, a case of water, maybe a change of clothes, a flashlight, some batteries, some canned food, things of that nature, and make sure that bin is able to fit in your car or your SUV. Make sure it fits in the trunk. And at least if there's an emergency situation where you need to evacuate, you take that bin, you put it in your trunk, and you get the hell out of Dodge. And then things may be a little more comfortable for you, knowing that you have some things available for you immediately. And that's the best advice I could give on that subject, because at any given time, anything can happen now. Anything. We're
right.
seeing this on a daily basis now, and things are probably going to get worse. That's the sad part.
That is the sad part. And Scott, when I start seeing earthquakes in Africa, I always take note, not only because I live in South Africa, but because Africa seems to be the most stable continent. And earthquakes in Africa are extremely rare. I haven't seen any in many years. So when I start seeing earthquakes in Africa, I realize that something is going on and things are happening. And to me, it's a signal. Earthquakes in Africa are always a signal something is going on. And that something is something outside the Earth's atmosphere, possibly several objects influencing the Earth and magnetically, and causing earthquake activity to increase.
I wanted to just check something out while we're here. Let's take a look and let's see what's going on. Doctor, you know what, just in the past, maybe 6 weeks or more, there have been several earthquakes.
Yes.
In South Africa and in the surrounding areas.
That's right.
Yeah, we're looking at, there was a nice magnitude 5.7 2 hours ago in Peru. Let's see the depth. 69 kilometers.
Yeah.
Not quite to the mantle, but still concerning. 11 hours ago, another small earthquake, magnitude 2.54, Yellowstone. Yeah. And what's this one up here? 1.79, Lakeside, Montana. These earthquakes are just been keeping track of what's happening up here in Yellowstone, because it is very concerning. Once again, you're seeing a small swarm of earthquakes right along the San Andreas Fault, all the way to the Mexican border of Southern California. We just have to keep up with all of this information. Now, looky here.
Wow.
Your earthquake was removed.
Oh my.
Mozambique.
Yes.
Here was the one.
But you took a photograph of it.
Oh yeah, I have the evidence. I'm good with that screen capture. I get it. I want to see. This was very shallow quake, the 5.2 in the Indian Ocean, 10 kilometers. Let's see what's happening here in Sumatra. Now that's weird. No depth.
Zero.
Zero.
My goodness, a surface quake?
Magnitude 5.1.
Wow.
Australia reported that it was felt. Magnitude 2.7. 5 kilometers deep. You would definitely feel that if you were close by the epicenter.
Yeah.
Magnitude 4.5, Vanuatu. 123 kilometers. It's down just into the mantle.
Yes.
Yes, so I mean, it's definitely to the point now where you could see these earthquakes are 1 hour or less than 1 hour, the ones that are in red.
Mm-hmm.
Oh, that's a deep one, 235 kilometers.
Mm-hmm. Oh, yes.
Decently deep. And we do have a situation rolling around with our sun, once again, with the coronal holes coming towards the sun. Yesterday, I noticed a small one forming that would be pretty much dead on Earth facing. And we'll take a quick look at it now. It was
That's quite a
forming right
coronal
here.
hole there.
Yeah. This one here will be Earth facing. Seems to be closing and opening, closing and opening. So we'll see how that stream goes. But you can see the whole northern hemisphere up here.
Yes.
All the way through here. This is all.
Oh, that's huge.
It's actually connected from the north to the south.
Yes, it is. I can see that. Amazing.
Yeah, so here we go once again. Things were actually looking, somewhat okay. But take a look at the difference in the half of the sun. Semi-normal conditions here, totally obliterated here.
Yes.
Somewhat normal, somewhat. I use that terminology very, very lightly. You can see there's no corona being emitted from the top of the sun. Nothing, zero. Nothing at the bottom. Nothing.
Yes.
But there's nothing wrong. There's nothing wrong. Don't worry.
Yeah. Yes, well, we have the brown dwarf stars are basically drawing the sun's magnetic field lines right out of the sun. And then the magnetic field lines are connecting at the brown dwarf stars inside them. And then the particles flow along the magnetic field lines. So that's what's causing these coronal holes. And look at the size of that. That's the X-ray coronal hole. Oh my God. It's
That's
huge.
Bad. Oh. Yeah, still loading. Yeah, there we go.
That is at least 50%. That's more than 50%, I think, of the surface of the sun is an X-ray coronal hole.
Yeah. I started noticing this a few days ago, and sometimes I when I do these short videos, letting everybody know what is happening with the sun, what is occurring. Sometimes I think that maybe people are just not even interested in this, but ladies and gentlemen, this is definitely part of what we're looking at. This is the damage that is being done to the sun. This is not a joke. This is definitely something to be concerned about. That's pretty bad. That's pretty deep. I mean, you can see how the corona, you can see how it's just dissipating, just disappearing. And it's connected now from the very top all the way through to the bottom. One big hole.
That's right.
But again, there's nothing wrong. But in fact, everything is wrong, folks. Everything. Yeah, it's pretty.
It's amazing. It's what is happening to our sun is amazing.
Yeah, it's very sad that things happen. And while we're at it, take a quick look at some of the magnetosphere information real quick with everybody, because we just saw some last couple of days, 21st, 22nd, 23rd, we saw some really critical situations with our magnetopause and our magnetosphere. And as I have mentioned before, folks, we have a situation, our magnetosphere, it protects our planet. We lose it, we're gone.
That's right.
We don't exist anymore, any longer.
That's right. We don't. Oh my goodness. Look at all those kinks In the magneto, oh my goodness.
And this is only a short time frame.
That's right.
You're only looking at about maybe 45 minutes, if that.
Oh my goodness. That bow shock should not be doing that. The only way it could do that if it's getting hit by stellar wind from different directions,
I'm going to
like
take
from the side.
I'm going to take this back 200 frames, and I'll just speed it up so it doesn't take too long. But we're going to go back in time, folks, just a little bit to show you more of what's happening. This will load, but you could see how the damage being done, and you can see where this this heavy, intense energy coming from behind the Earth, from the dark side of the Earth.
Yes. Yeah, the density there at the bow shock tells me there's a lot of particles hitting. So, and they must be quite energized for us to see so many particles coming in from the backside, from the night side. There's definitely a lot hitting our magnetosphere. So it's no wonder we're getting so many earthquakes. Look at that. When it kinks like that, it tells me it's getting hit by more than one solar wind. Well, the other one, we'd call it a stellar wind. When it kinks like that.
That's just...
it's amazing. Truly is what's happening here.
Look at this, Jesus.
Yes, there's a lot of particles coming in. Don't forget, when the Earth is hit by the fast solar wind, the effects last about 4 days on the ionosphere. And in that time, we should be getting increased volcanic and earthquake activity. Oh my goodness.
This is going back to the 21st. This is when all hell started breaking loose.
Oh, yeah. Oh, my goodness. That is not normal. You see, you actually see at that point 2 lines of particles hitting the bow shock at an angle. That to me would mean there are 2 stellar winds. One below the sun, one above the sun, hitting the bow shock. Look at that. It's not supposed to do that.
No, absolutely not. I've never seen anything like this except for a couple of times now. Back in 2012, I believe 2014, and twice in 2016. BP Earthwatch definitely caught this on all of those occasions. There were several other YouTube channels that reported on this when this was happening back in those years. Seemed like it was happening every 2 years intensely like this. But now, you know, it happened twice in 2016, April and October. And it's happened now twice this year.
That's right. And Scott, do you see above the Earth, there was this line of high density particles coming in? You see where it's red? That's
Here?
right.
Yeah.
That's right. So that to me is a stream of particles coming in. It's not coming from the direction that it should be coming in, which is from the sun, which would be coming from the right. It's coming from, looks like, above the Earth in this diagram. And then I would say there is therefore a brown dwarf star in that direction that is emitting particles. Well, it's generating a stellar wind or a particle flux transfer. So that particle flux is hitting the Earth in that position. And that's what's causing this to fall. I think our magnetosphere is being hit by several stellar winds, because don't forget there are several brown dwarf stars in the solar system. We don't even know how many there are. There could be quite a few. And if they all have gotten to the stage where they are producing stellar wind, that is, they're having, oh my goodness, look at that.
This is like, each click of the mouse is like one of those WTF OMG moments, because each click you're getting something completely so erratic that you don't even know what to think.
Yeah, you see the two particle fluxes, you can actually see one is going slightly up and one slightly down, and that's hitting the bow shock, because the bow shock is produced where the stellar wind hits the magnetosphere. So it's actually produced by the solar wind that is hitting it.
You see how far it got pushed back?
I know.
Halfway through the satellite belt.
Exactly. It's amazing. And it's totally the wrong shape. It cannot be that shape. If the magnetosphere is just being hit by solar wind, it's not possible. The solar wind comes from only one direction, the sun. So it's got to be hit by stellar wind from different directions to do this. Look at that. It's totally amazing.
Now, Doctor, what would you say if someone stood here in front of you right now and said, this is nothing to worry about, you're exaggerating?
Well, I would say, well, I think you're wrong. I mean, this is unbelievable what's happening, what we see happening to our bow shock. And it goes with everything that we know is happening in the solar system anyway. We know there are several stars in the inner solar system. Stars produce stellar wind. Stellar wind will hit our magnetosphere. Our magnetosphere will therefore start doing crazy things like this because they're coming from random directions now.
Now, looking at this clip, and I already know the answer, but I just want to ask you for our viewing audience. As you can see, the bow shock has been pushed way off of its target. Oh, yes. Way off. Now, what would cause it to leave its normal position and be pushed out away from the Earth at this portion?
Yes. Well, the only thing I can think of is that there is a stellar wind coming from the night side of Earth, so behind the Earth. It's actually pushing the bow shock in the opposite direction. And
look at this.
Goodbye. Oh my!
Goodbye. It's gone.
Oh, if it's oh my goodness! Look at all those particles going right into the Earth.
I have to take a screenshot of that, ladies and gentlemen, so just hold on and bear with me.
It just about completely collapsed at this point, the magnetopoles.
And that was on June 21st, 2017 at 11:41 p.m. UTC time.
I mean, the north side is just gone. I mean, the top side above the Earth.
It's like out of the frame.
It is.
I'm afraid to click the next screen. Oh, my Lord.
Oh, my. This is amazing.
And if you could see here, all of this radiation, all of this right into the Earth.
That's right.
Woo.
Oh, my. And that's very strong because some of it is red. That's high density of particles going straight in.
Look at this.
Okay, now you see the bow shock actually bends with some of it coming behind the Earth. That's another sign that we have stellar wind coming from the night side. Jeez. Oh, my.
Look at this.
Look at that. Yes. Huge amounts of particles coming straight in from the night side now.
I don't know. This is just
it's unbelievable.
this part for me is scary because, I know if something would ever tragically happen to our magnetosphere, we're all doomed. You can forget about asteroids, meteors impacting the Earth. You can forget about Planet X. You can forget about Nibiru, Herculus. You can just forget about all of that, because that goes right out the door if our magnetosphere gets damaged or completely destroyed. We're done.
Right.
We're done.
That's right, because without our magnetosphere, our atmosphere would start being stripped off by the solar wind, and we would basically start losing our atmosphere, and we cannot live without it.
I'm going to go through a couple more of these clips, and this is just...
It's amazing.
Really bad. Look at this.
Yes, I mean, the only way that could be happening to the bow shock, again, as I said, is if there are several stellar winds hitting the magnetosphere. And the magnetosphere is trying to, it tries to, the Earth's magnetic field will against it, and that's why we see the bow shock doing that. That's the region where the particles coming from the other stars or the sun are slowed down dramatically by the impact with the magnetosphere. So the bow shock is the boundary between these stellar winds and the magnetosphere. It's what defines the boundary.
Now, ladies and gentlemen, for all of you that want to see what it should kind of normally be.
Yeah, that's right.
It kind of normally be like this, where it's deflecting this solar radiation, this solar energy, all of this plasma coming from the sun. It will bounce off. It's our deflection shield. You can see it's kind of red, kind of yellow. Look at the color key over here. The blues are lower densities, but we should kind of be in the green, maybe a little bit of yellow, but you can see we're looking at a very intense situation. And it kind of calmed down at this point going into the 22nd. This is 3:37 p.m. on the 22nd, but I don't think it lasts. I think it starts to occur again, and you can see how it's flexing. And then there's more density coming in. There it goes again. Now, you know what, Doctor? I wanted to ask you one question while we're on the subject of our magnetopause. Excuse me. There's been a lot of questions, a lot of talk about CERN being able to do this to our magnetopause. When they fire up CERN, and they're down there smashing all of these particles in this hadron collider. But based on what was happening on the sun and the speed of the solar wind, which almost reached 2 million, actually it did reach 2 million miles per hour.
Yes.
So, I sometimes have, my thoughts and say, okay, well, maybe. Is CERN that powerful to do this to our magnetopause?
I think, Scott, that CERN is not actually that powerful. I think the Earth's magnetic field is far stronger than what CERN generates. But even then, if CERN is able to generate a magnetic field in the opposite direction to the Earth's magnetic field, it could possibly weaken it a little bit. But I have reservations about saying that CERN is causing this. I don't think so. If we look at the bow shock, we're not looking at our magnetosphere weakening as such. We are looking at our magnetosphere trying to cope with stellar wind coming from several directions. I think.
I don't know what just happened there. I don't know what just happened to my screen. It just went.
Oh my, it went back.
Maybe they didn't want us looking at it. They didn't want us looking at it anymore.
Yeah.
We're going to take a real quick look at
Yeah.
the magnetosphere.
Uh-huh.
See what's happening
So
here.
I don't think it's CERN, to tell you the truth. I think it's coming from outside the Earth, not from the inside. What's causing
Yeah, and
this?
I couldn't, I mean, with dealing with CERN, I don't see how they would be able to generate that amount of energy coming from the opposite direction of the sun.
Exactly.
It just doesn't make any sense to me. I know CERN is probably very powerful, and I just don't, I don't know. I'm not buying that this is CERN firing up and causing this type of situation, but we're going to go back here. Let me adjust this and see what happens on the on this model.
Doesn't look too bad at the moment.
Well, this is actually for today, 1752 UT. It's going to jump back. I went back in time a little bit here.
Good.
I went back to the 22nd. Oh, I actually, you know what?
Yeah.
I used the wrong model.
Oh, okay. But we can see the magnetic field lines pinching there, and that means magnetic reconnections and means particles will be coming in from the night side. Yeah. Oh, that is high density hitting the bow shock, that's for sure.
This is today.
Oh my. That's very high density.
You can see the closed loop lines, the red lines, folks, back here. They're already reversing and flipping backwards.
That's right. And we see there are magnetic reconnections happening there for sure, because we see the magnetic field lines pinching towards each other on the night side. And that will bring particles into the Earth from the night side. But what, for me, that very high density at the bow shock, that is very strange. That's extremely high.
Yeah, we're going to go back in time to the 22nd when we saw all of the occurrences. This is going back to the 22nd, what we were just looking at at the magnetopause.
Yes. You see the close field. Oh my.
Oh Jesus. Oh boy. Let's just take it back here a little bit. Yeah.
Oh, that's a mess.
I mean, that's basically all. That's the only observation that you could make right now is that is one hell of a mess.
Oh my.
I mean, I don't know what else to say, folks. I mean, that's just like damage right there.
That's right. So that's why, you see, we saw the bow shock doing some crazy things. And now we're seeing what's happening inside the magnetosphere. It's going crazy as well. Look at that.
Yeah,
so it's basically, we see it happening on both sides. The magnetosphere is getting hit from different directions. And in the end, it just reacting to all these things and looks like it's going crazy.
Look at that.
Oh my.
Look at this. Look at this.
Yes. Very high density
My
there.
God.
Unbelievable.
And this was on the 22nd, 1453.
Yes.
What is that? 4 o'clock?
That's
2 o'clock.
7 minutes to 3.
Yeah.
Yeah. So it's nearly 3 o'clock UTC time.
Oh boy. Yeah, this gets my blood pressure going. Look at this. Look at this wave.
Yes. Amazing.
My God.
it's so broad.
You know,
That means,
I'll be
yeah.
quite honest. I've never even seen this type of reaction with a high solar wind impacting the Earth.
I haven't either, Scott. I think there has to be several stellar winds impacting the magnetosphere for us to get this kind of density and the width of it, this kind of width.
Look at this.
Again, it's amazing. Oh my.
My.
It's,
and it just doesn't get any better. It keeps reacting like this all
That's
the way
right.
through. The starts like I think on the 20th, 21st, 22nd, 23rd. Now we've moved into the 21st, and it's still reacting this way. We'll take a look real quick at the solar wind and
oh my, you can see the high density there as well. Very high.
and this is today.
And look how the arrows almost reversed there. Yeah, they did reverse there.
Yeah, they're all going back towards Earth.
And you see they do that as on a wave pattern, as if a wave is going through. And that shows you there's an object on the Earth's night side, so behind the Earth, that must be causing this kind of reaction.
I just took it back about, I think, 200 frames, 200 or 300 frames.
Wow.
This is going back to the early morning hours, 5, 6 a.m. It's pretty intense.
It is.
That's just, yeah.
Yeah, so we have evidence that planet Earth is being hit by several stellar winds. And that's what it's all about. And that's what Carlos Ferrada said would happen. He said it would, this object, and he only saw one object, would be causing the Earth a lot of problems. And we are seeing it now.
Yeah, there's no doubt. We are definitely seeing a lot. There is just absolutely no doubt. And like I always say, we are living in the sign of times, ladies and gentlemen. There's just absolutely no doubt about it. It makes me want to say, hey, buckle up, baby. It's time to go for a ride, and we're all in for a ride of our lives. That's basically all we could do. You take things day by day. You continue your research. You continue your observations. We will continue our reporting for everyone. And that's what this is all about. So all of us have a general understanding of what is happening, why it's happening. And we're going to continue, each and every day. We're going to go ahead and end our live stream for today, ladies and gentlemen. And I really appreciate all of you joining us this Saturday afternoon. And depending on the doctor's schedule, tomorrow we may have another live stream, because we may be looking at more of this evidence. And she's going to be writing another paper very, very soon, and we will definitely have that up in a live stream. And probably by the end of next week, we're going to be going into a little bit of a different format with the doctor, and she's going to be more available to all of us throughout the morning and the early afternoon and the late afternoon. And we're probably going to have several live streams, or at least a lot of reporting coming in. And she's going to be reporting on a lot of observations that she's going to be making, and she'll have a lot more time to center her attention on what's happening, and she'll be with us a lot more. Doctor, any last words for everybody?
Well, as always, Scott, thank you. And I would like to say that even though we are facing bad times on Earth, that we have a creator, and and I think he's there for every one of us. And I think we should just try and get to know him.
I agree. I agree 150%. I definitely agree. Well, ladies and gentlemen, once again, I'd like to thank each and every one of you for being with us. Make sure that you are subscribed to both the Nibiru channel and also the Planet X News channel. And, if you happen to miss one of the live streams, folks, don't worry about it. The live stream gets converted into a video and you can watch it at any time. I also urge you to double check your subscriptions to any of the YouTube channels, including this channel. Make sure you check your subscriptions. Make sure you check your notifications, because from time to time, suspiciously, they get kicked back to a default setting and you may not get a notification. Or just make a habit of coming back to the channel each and every day or several times a day and check in with us. But this is Scott and our physicist from Planet X News and the Nibiru channel. I'd like to thank each and every one of you for joining us, and God bless all of you.